What is the formula for our permutation? That is n p r is equal to n factorial over n minus r factorial. We have 9 different boys. They can occupy 9 different places. Therefore, it is 9 factorial. What does type 1 question says? You take it as one unit where we have one thing more than one time. Hello my dear students, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram faculty, a temple of excellence, Mysore. Today, in this session, we will be learning various types of permutation. But before going to the various types of permutation, let us recall what are the concepts we have learned in our previous session. Okay, so the first one is definition of permutations and combination. So as I have given so many examples on permutations and combinations, permutations means arrangement of objects, whereas combination nothing but selections of objects. Okay, so then we have learned about fundamental principle of counting. Okay, for example, when there are m different objects and n different objects, they are not occurring simultaneously, then we apply the sum rule. That is, we take it as m plus n ways. Whereas when two different objects, they are occurring simultaneously, we take it as m into n ways. That is our product rule. Okay, so the next thing we have learnt is how to write a factorial of a given number. Suppose you have n factorial, then we write it as n into n minus 1 into n minus 2 into to the last term 1. Okay, suppose you have 4 factorial, we write it as 4 into 3 into 2 into 1. Okay, so this is how we have learned to write the factorial. Why? Because the factorial is used in the formula of the permutation. What is the formula for our permutation? That is n p r is equal to n factorial over n minus r factorial. Okay, so this is what about the formula of permutation we have learned. So we have learned one more thing concept, that is permutation with repetition and without repetition. What do you mean by with repetition? When n number of object repeats in r number of places, then we write it as n power r. Okay, so the total number of permutation when n objects are repeating in r number of places, we write it as n power r. Okay, so when without repetition means objects are not repeating. Okay, so I have given an example of arranging the books in a shelf. Okay, when one place is occupied by the one book, the only two places can be filled by other two books. So what type of permutation we take there? There we take n factorial. Okay, also we have solved simple problems on types of permutations, and also we have found the value of n and r in our previous session. Okay, so in this session we will be learning various types of permutation. So here we have many types of permutations. In this session, I'll be taking type 1, type 2, type 3, type 4. So let us learn them one by one. Okay, so the first one is when a certain number of things always occur together. Okay, when a certain number of things always occur together. Here I have taken an example. Okay, in how many ways 7 people be seated in a row for a photograph if 2 particular people always want to be together? So this is my question. So we have to arrange 7 peoples for a photograph so that 2 peoples are always together. Okay, so let me take 7 places here now. 1, 2, 3, 4, 5, 6, 7. Okay, so we know that 7 different objects can be arranged in 7 factorial ways. Okay, so that is what permutation without repetition. But here, what 2 peoples always sit together. They may sit together in any of the places. Okay, they may sit here, they may sit there. Okay, so I'll say these 2 people's place is fixed. Okay, they can be seated in 2 different ways. Okay, suppose I take A, B here. A can be seated here, B can be seated here, or B can be seated here, or A can be seated here. So we have 2 different arrangements for 2 people. Okay, so that's why number of ways here is first one. We are just talking about the 2 people who are always been sitting together. So how many ways they can be arranged? They can be arranged in 2 factorial ways. Okay, how many places are remaining now? 1, 2, 3, 4, 5. 5 places are remaining. Here the 2 places is already occupied by the 2 people. So we have to take this unit as only 1 unit. Okay, so how many places we have now? 5 plus 1, that is 6 places we have. Okay, you should take this as 1 unit because it can't be altered. Okay, only people can change the places, the place will remain same. So therefore we should take it as 1 unit. Along with the 5 units, the total seats are now 6. Okay, so therefore 6 different objects can be arranged in 6 factorial ways. Therefore this is 6 factorial. Okay, I'll explain once again. We have 7 people. Okay, so they are to be seated for a photograph where 2 people always together. Okay, they'll sit always together. So this 2 people, it may be A or B, B or A. Okay, so therefore there will be 2 factorial ways. So this should be taken as 1 unit, and the remaining 5 places along with this will become 6 places. So therefore my total number of ways here is 6 factorial into 2 factorial. So this is how when a certain number of things always occur together takes place. So you should take as 1 unit when the things are repeating. So the next question, in how many ways 7 maths book, 8 statistics book, 4 accountancy books can be arranged in a shelf if maths books are always together? So how many books we have for maths? We have 7 books and 8 statistics books and 4 accountancy books. So total how many books we have? That is 8 plus 4, 12. 12 plus 7, how much? 19 books we have. Okay, so but they are asking 7 maths books should be always together, whereas 8 statistics books and 4 account books can be arranged in different ways. Okay, so therefore this 7 maths book should be taken as 1 unit. That should be taken as 1 unit, whereas here the remaining 8 statistics books and 4 accountancy books, that can be arranged in different ways. So how many ways we have? 8 plus 1, 9, 9 plus 4, 13 ways. So 13 different objects are arranged in 13 factorial ways. So therefore our number of ways here is 13 factorial. What about this 7 mathematics book? 7 mathematics books can also change their place. Okay, so we have 7 maths books. They can occupy 7 different places there itself. So therefore it is 7 factorial. So therefore my total number of permutation for this problem is 13 factorial into 7 factorial, because all 7 maths books should be taken as 1 unit. So therefore 1 plus 8 plus 4 we should assume that we have only 13 books. So therefore 13 different books arranged in 13 different places, nothing but 13 factorial. Whereas in 1 unit we have again 7 maths book. They can be arranged in different ways or 7 ways. Therefore it is 7 factorial. Therefore my total number of ways for this is 13 factorial into 7 factorial. So the next problem is, in how many ways can 3 boys and 4 girls be arranged in a row so that all the 3 boys are always together? So here we have 3 boys and 4 girls, okay, who have to be arranged. So how many places we will be having? We will be having 7 places. But the condition is here, the 3 boys are always together. Okay, so the 3 boys are always together. So therefore, what shall I do here now? So look here. So I'll write 3 boys as 1 unit. So this one you should consider it as 1 unit. And remaining 4 girls can be arranged in 4 different places. However you want, you can arrange. Okay, so we have 4 girls here. So total how many units we have? We have 5 number of units. So therefore, we should consider it as 5 different objects are arranging. So therefore, here total number of ways. Okay, so total number of ways is how much? 4 plus 1, 5 factorial. But what about boys? Boys can also be change their places in those 1 unit only. Okay, so therefore the arrangement of boys can be taken it as 3 factorial. Okay, so therefore my total number of ways for arranging 3 boys and 4 girls where always 3 boys sit together is 5 factorial into 3 factorial. So this is about my type 1, because you can see here when a certain number of things always occur together. Okay, so here in the first case 2 people was always together. In the second case 7 maths books was always together. Here 3 boys were always together. So when certain things are always together, we should consider those as 1 unit, and the remaining factorial along with those factorial is my total number of permutations. Okay, so the next type of permutation, when certain number of things occurring together more than one type. So in previous examples we have considered only one type. Okay, so here we can see more than one type. So this is also simple as the previous one. The same question I have taken here, in how many ways can 7 maths book, 8 statistics book and 4 accountancy books can be arranged in a shelf if same books are always together. Okay, so the same question was taken previously where only 7 maths books was arranged. Here we have to arrange 7 maths books as 1 unit and 8 stats books as 1 unit and 4 accountancy books as 1 unit. So total how many units we have? We have only 3 units, 1, 1, 1. So total we have 3 units. So therefore 3 different objects are arranging here. So therefore here what? My total number of permutations, that is number of ways, here is 3 factorial. Okay, so this is 3 factorial. So what about my 7 maths books here? Okay, 7 maths books can be arranged there itself. Therefore that can be written as 7 factorial. Similarly, my 8 statistics books and similarly my 4 accountancy books. So therefore, my total number of ways here is 3 factorial into 7 factorial into 8 factorial into 4 factorial. This one we can take as an example when more than one type are always occurring together. Okay, so here we should consider these as 3 units, whereas 7 maths books can be arranged there itself, 8 stat books can also be arranged, similarly for accountancy books. So therefore my total number of permutations will be 3 factorial, 7 factorial, 8 factorial into 4 factorial. Okay, so the next type, when certain thing of one type do not occur together. So in the previous examples we have learned there are one type where they always occur together, like 3 boys are always occurring together, 7 maths should be arranged together, like that. But here no things are repeated. Okay, so that is no, do not occur together, things do not occur together. Then what is about my total number of permutations or total number of arrangements? So let me see, we have taken an example, in how many ways 9 boys and 6 girls can be arranged in a row if no 2 girls are together. Okay, so we have here 9 boys. So remember the word no 2 girls are arranged together. That means girls cannot be together. They have to be alternatively placed between boys. So how many boys we have now? So we have 9 boys. Okay, so let me take it as B1, B2, B3, B4, B5, B6, B7, B8, B9. So these are boys. Girls must be filled in between the boys. So how many empty places we have? We can start filling from the first. So these are the empty places where girls can occupy their places because they can't be together. Okay, so how many places we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 different places for girls. And we have to fill how many girls? Only 6 girls. Okay, so therefore 6 girls can occupy any 6 places in between the boys, but we have 10 places. Okay, so remember that. So therefore here number of ways. What happens here? Number of ways for arranging girls. For arranging girls, we have 10 number of places where only 6 girls can occupy the places. So therefore, my permutation can be written in the form 10p6. This is about number of arranging the girls. Whereas we have boys also, okay. We have 9 different boys. They can occupy 9 different places. Therefore, it is 9 factorial. It is 9 factorial. I'll explain once again. So we have 9 boys and 6 girls where no 2 girls are together. So we have 9 boys. Girls must be occupy the places in between the boys because no 2 girls cannot sit together or stand together. Okay. So therefore, if you observe, we can fill either from the first or from the last. So any 6 places they can occupy. So therefore, we have 10 options for girls. So therefore, my permutation for arranging the girls in between boys is 10p6 and arrangement of boys is 9 factorial. Therefore, my total number of permutation is 10p6 into 9 factorial. Next question. And next type. When no 2 of a certain things do not occur together. So, no 2 of a certain things do not occur together. Just example, in how many ways 7 students, 4 teachers can be seated in a row such that no 2 teachers are together. So, we have 7 students here. Okay, 7 students, I'll write it as S1, S2, S3, S4, S5, S6, S7. So these are 7 students and 4 teachers can be seated in a row such that no 2 teachers are together. So as the previous example only, so teachers have to be filled in the place of students here. Okay, so how many places we have? We have 1, 2, 3, 4, 5, 6, 7, 8 places. So teachers can be arranged in 8 different places, but the choice is only for 4 teachers. So therefore it is 8p4, whereas students can be arranged in 7 factorial ways. So therefore my total number of ways, is 8p4 into 7 factorial because 4 teachers can be arranged in 8 different places in between students because no 2 teachers are together. Okay, so the next question. 5 men and 4 women are to be seated in a row so that women occupy the even places. How many such arrangements are possible? So it is very clear. We have 5 men and 4 women. Women occupy even places. Okay, so we have 5 men. So let me write M, 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 M. So these are 5 men. Women occupy even places means obviously they will take the 2nd place, 4th place, 6th place and 8th place. Okay, so this is all about the arrangement. We are clear. What about my total number of permutations here? Okay, so my total number of permutations. Okay, so my total number of permutations. See, 5 different men we have. They can occupy 5 different places. So therefore, it is 5 factorial. Similarly, 4 women can occupy 4 different places. So therefore, their factorial is 4 factorial. So therefore, my total number of permutations where men and women can arrange, where women can occupy the even places is 5 factorial into 4 factorial. Next question. In how many ways can 6 boys, okay, we have 6 boys, 6 girls that can be arranged in a row so that all girls are together, all boys are together, no 2 girls are together, boys and girls arranged alternatively, two particular girls are always together. So we have to apply all the concepts of type 1, type 2, type 3 and type 4 in one particular question. So let me go by one. Okay. So my first question is, given what? We have 6 boys and 6 girls. Okay. So therefore, how many total members we have? We have 12 members. Total 12 members we have. First question is, all girls are together. So all girls are together means this is of type 1 question. What does type 1 question says? You take it as one unit where we have one thing more than one time. Okay, so they're always together. So my first question, all girls are together. So all girls are means 6 girls are together. Okay, so remaining 1, 2, 3, 4, 5, 6. These are filled by boys. So this should be taken as one unit. Okay, this should be taken as one unit. Remaining 6 units for boys. So therefore, my total number of ways here. Okay, so my total number of ways here is 1 plus 6 is 7 factorial into 6 factorial. Why 6 factorial? Because 6 girls can be seated in 6 different ways. So therefore 6 factorial. Total number of units is 7 factorial. So therefore answer is 7 factorial into 6 factorial. The same answer is for the boys. All boys are together means what? So we have taken question number B. All boys are together means 6 boys must be taken as one unit. Okay, so this is one unit. Remaining 6 places can be filled by girls. So here also my total number of permutations will be 7 factorial into 6 factorial. Okay, 7 factorial into 6 factorial. Next, no 2 girls are together. No 2 girls are together. So total how many girls we have? We have 6 girls and 6 boys. No 2 girls are together means what? They have to be arranged alternatively in between boys and girls. Okay. So 6 boys we have B1, B2, B3, B4, B5, B6. Okay. They have to be arranged in 6 different ways. So look at the question. So no 2 girls are together. Okay, so therefore, see here, how many places are left for girls here? 1, 2, 3, 4, 5, 6, 7. 7 places we have. So all the 6 girls can be seated from the first or from the last or in between boys. Okay, so there because 2 girls cannot be together. So therefore, my total number of permutations. Okay, so total number of ways. Here, I can say how much? So 7 out of 6 for girls and 6 different boys can be seated in 6 different places. So therefore, my total number of permutation for this question is 7p6 into 6 factorial. Okay, next question. So boys and girls arranged alternatively. This is very simple. So after each boy, we can arrange girl. First, we can either take boy, girl or girl, boy. Okay. So boys and girls means, so first start with boy, girl, boy, girl, boy, girl, boy, girl. So B, G and BG. Okay. So we have 1, 2, 3, 4, 5, 6 boys. 1, 2, 3, 4, 5, 6 girls. So therefore here my total number of ways. Okay. My total number of ways for this question is 6 boys can be arranged in 6 factorial ways. 6 girls can be arranged in 6 factorial ways. So therefore this is 6 factorial into 6 factorial. Next question. 2 particular girls are always together. Only 2 girls are always together. Remember, not all the 6 girls. So what happens when 2 girls are always together? So let me look at this question here. How many girls we have? 6 girls. In 6 girls, only 2 girls are always together. Okay. So 2 girls are always together must be taken it as 1 unit. Okay. And arrangement between them should be taken as 2 factorial. How many girls are remaining? So we are remaining with 4 girls and 6 boys. Okay, so total how much we have now? 1 plus 4 plus 6. That is how much? 11. Okay, so 11. So 11 factorial of arrangements and 2 factorials for 2 girls. So therefore, total number of ways here is 11 factorial into 2 factorial. What is this 11? Because 2 girls are together. Okay. So therefore, 2 factorial arrangements can be made between them. As I already said, you have girl A, girl B. First, A can be seated, after that B can be seated, or it can be seated in this form also, that is BA. So there may be 2 arrangement between them. But what about the total arrangement? Since we have taken 2 girls as 1 unit, remaining 4 girls and remaining 6 boys can be seated in many different ways. Okay, they can be together or can they like boys, girls, girls, boys, like that. So therefore, 2 girls is taken as 1 unit. Okay, so therefore, the remaining units is 1 plus 4 plus 6, that is 11 objects we can take, or 11 things we can take. So therefore, 11 objects in different ways is 11 factorial, and 2 girls in 1 unit has 2 factorial. So therefore, my total number of permutation here is 11 factorial by into 2 factorial. Okay, so this is all about today's session. We have learned 4 different types of permutations, where the things repeat, where the things do not repeat, where the things will not occur together and they will occur together. So this is how we will calculate the permutation in different ways. Okay, so we will learn other types of permutations in the next sessions. So until then, keep watching, keep learning and keep exploring. Thank you.